Okie doke, what's up y'all? So this is going to be a really short video. I'm just going to go through some examples of the stuff that was in the last bit of chapter 5. And then I'll put the slides on Blackboard like I usually do, so you should check those out too, because that's what I'm going off of here. But I'm just going to do like a compressed version of what I would do in class. So I'm skipping 5.6. 5.7 has to do with solving equations, so we've already done some of this stuff. It's just going to throw in some decimal numbers now, so you're going to have to do stuff like this. Negative 1.5x equals 9.36. So the strategy is just to isolate the variable. What's being done here is multiplication by negative 1.5, so this is what I do. Divide by negative 1.5. And being as I did that there, I have to do it here. These 1.5's cancel, so you just have x here, and then you have to do 9.6 divided by negative 1.5. Just make sure that's recording. So what I would do over here is take it over, do 9.36 divided by 1.5, and so we just learned this trick where you go like this, move the decimals over 1, bring the decimal up, 15 into 93, 6, 7, nope, 6. Or is it 7? Damn it. What's going on here? Right, there we go. So here's a situation where here's my remainder, but I can just keep bringing zeros out. So drop another 0 down, 15 into 60 is 4, and then it stops. So it's 6.24, and remember it's a positive divided by a negative, so it's negative 6.24. Always worth checking your answer, just to make sure. So to check this, you would say, is negative 1.5 multiplied by negative 6.24 equal to 9.36? And if you're doing this on your own, outside of the context of the test, I would use a calculator to do this. I don't have one. Actually, I do. This is just, this is just for you as you're practicing to see if you got the answer correct. 1.5 times 6.24 is 9.36. Good, so that was done correctly. All right. Cool, so that's definitely worth a lot of practice. I put a bunch of those in the homework for this section. So get really comfortable with that. Now there's a new thing that's coming up. You're gonna up the difficulty a little bit. And that is, this last thing that I put up here had one variable term equals just a number. But you're gonna get to the point where you're gonna have multiple variable terms. So something like this. So this is an equation that has a variable term here, a number term here, variable term here, a number term here. And here's the equal sign, so there's a left side and a right side. So here's the drill. You want to get all the variable terms on one side, and you want to get all the number terms on the other side, because they're like terms. And then because they're like terms, they can be combined. So here's what I would start with. Add 7 to both sides. This cancels those 7's out. Over here, just left 10x, 2x, and then 13 plus 7 is 20. And now here's the part that a lot of algebra students, I've noticed that a lot of people wonder if they can do this step. Here's what you can do. 2x is its own thing. It might as well just be a number. 2x, it's 2 whatevers. So you can just minus 2x on both sides. You can manipulate that just like you manipulate 7. Positive 2x, so minus 2x on both sides. That cancels the 2x here and just leaves you with 20. And then 10x minus 2x is 8x. So see what I did was I collected the number terms over here and I collected the variable terms over here. Why did I do that? Because they're like terms and they can be combined. And now you just divide out the coefficient, leaving you with just x. And then 20 divided by 8 is 5 over 4. Which you could write this as a decimal if you wanted to. By just going like this. Bring the decimal up. 1.25. Whoops. Yeah, so any way you want to, you do it. 5/4 is the exact same thing. I mean, you could make it a mixed number if you wanted to too. What was it, 1 and 1/4? So all 3 of these things are equivalent. I prefer this, like I told you guys, I like to keep my answer as an improper fraction. I mean, you'll probably see later that it starts to become easier to work with those things. Okay, so that's the trick with those. I mean, if you've never done this before, that's the revelation, that you can move this or this. You can move variable terms to the other side by just adding and subtracting. So let's say, just for instance, if this was a negative 2x, you could add 2x to both sides to get this to the other side. Sometimes I say move the negative 2x to the other side, and what I mean by that is add 2x to both sides, because it cancels it here and it puts it over here with the other sign. Alright, so let's do a couple more. Let's say 5.9x plus 67 equals 7.6x plus 16. Okay, now a lot of people ask, like, where do you start? I like to start with the numbers, with the plain numbers, and it really doesn't matter though. I mean, I could move the 7.6x over to this side, or I could move the 67 over to this side. I'm gonna have to do them both anyway, so some people do them all in one step. Here's what I'm gonna do first though, minus 67 from both sides. That cancels it here and puts it over here negative. So we get 5.9x equals 7.6x. Negative 67 plus 16. Can I do this in my mind? Negative 51. Now, okay, so I've collected the number terms together, these two, and I've combined them into one. Now collect the variable terms together and combine them into one. This is a positive 7.6x, so minus 7.6x on both sides. Cancels it there, puts it over here negative. Negative 7.6 plus 5.9. Negative 1.7x equals negative 51. And now you divide by negative 1.7. So x equals negative 51 divided by negative 1.7. It's a double negative, so the negatives cancel. And in order to do that, you gotta take it over here and do the longhand division. So I'm gonna do this thing again where I take the decimal point and move it out. (17) into 51, I'm just gonna guess it's 4. Nope, it's 3. Oh, sweet, exactly 3.
0